Hello and welcome again to question number 2, where we're going to look at motion under gravity. In this question, we are going to learn several skills when it comes to dealing with motion under gravity. It's a very simple question, but I'm going to use it to explain very important concepts. And let's go straight to the question and see what it has. We are given that a particle is projected vertically upwards with a speed of 30 meters per second from a point on a horizontal ground. Part 1, we are asked to show that the maximum height above the ground reached by the particle is 45 meters. You can see from the onset, this question appears to be so simple, but I'm going to use it to explain certain things. Number 1, this particle has been projected vertically upwards. What will happen to the speed? The speed is going to reduce. And at what rate is it going to reduce? First of all, when it comes to motion and gravity, we always assume or take it or neglect air resistance. And that makes sure that the acceleration is constant. The acceleration that the object has is referred to as acceleration due to gravity, and it has a magnitude of 10 meters per second squared. What that means is that if an object is released from some height, its velocity is going to increase by 10 meters per second every second. So that if it is released from a given height, its initial velocity is 0. After 1 second, how much will be its velocity? If the velocity is increasing by 10 meters per second every second, how much will be its velocity after 1 second? You will agree with me that its velocity after 1 second will be 10 meters per second. And then after a further 1 second, its velocity will again increase by 10. So after a total of 2 seconds, its velocity will be 20 meters per second. Again, after another 1 second, meaning a total of 3 seconds, its velocity will be 20 plus 10, which will be 30 meters per second. On and on like that until it continues indefinitely, right? Now, when an object is projected vertically upwards with a certain speed, then its velocity is going to decrease by 10 meters per second every second, because the acceleration now has a negative sign, which is minus 10 meters per second squared. That means that its velocity is going to decrease by 10 meters per second every second. So if it is projected by 30 meters per second, you can immediately tell that it will reach its maximum height after 3 seconds. Why? Look at that 30 meters per second. In 1 second, it will reduce and become 20 meters per second. In a further 1 second, meaning a total of 2 seconds, its velocity will be 10 meters per second. And finally, after a further 1 second, meaning a total of 3 seconds, its velocity will be 0. So at maximum height, the instantaneous velocity will be 0. It's very important to realize that. The other thing I want you to realize is this. This object has been projected vertically upwards with a speed of 30 meters per second. It will rise to maximum height where its velocity is 0 and then fall back to its point of projection. When it comes back to its point of projection, the speed will be the same as the speed with which it was projected vertically upwards. So it will have a speed of 30 meters per second. But of course, its velocity will be different, because its velocity will have a direction, and the direction is vertically downwards. So it was projected upwards with a speed of 30 meters per second. When it comes back to the point of projection, its speed will be 30 meters per second downwards. So you can see, by mentioning upwards and downwards, I'm giving it direction and I'm speaking about velocity. So the two velocities are going to be different in direction, but they will have the same magnitude. So one of the things that you should get from this video is that when an object is projected with a certain speed vertically upwards, it will come back to the same point of projection with the same speed. The next thing you should realize is that when it reaches maximum height, its velocity is momentarily or instantaneously 0. Okay, so at maximum height, its velocity is going to be 0. And then the height that it covers is equal to the height that it's going to cover on its way downwards. Why is that important? It's because of this. When we are projecting it, its displacement is 0. After a certain amount of time, it rises to maximum height. This time, we've been asked to show that this maximum height is 45 meters. So it rises to 45 meters, and then naturally it will fall back through a distance of 45 meters. But while the total distance covered is 90 meters, its total displacement is 0 when it comes back to the point of projection. How is that? I'd like you to remember the definition of displacement. It is distance in a specified direction. It is the length of the path between 2 points, and then we give that path a given direction. For example, when I say that the displacement is 0, I'm talking about this, the point of projection. It rises 45 meters. So when it is at its maximum height, the length of that path is 45 meters. So the displacement is 45 meters vertically upwards. When it falls through maybe 10 meters downwards like that, its total displacement will be 45 minus 10, which will be 35 meters, because I'm talking about the length of the path between where it is and where it was. And as it approaches the starting point, although time is increasing, you can see that the displacement is reducing until it comes back. When it comes back to the point of projection, the displacement is going to be 0 because it is at the starting point. That is very important. Something else. The time it takes to rise to maximum height will be equal to the time it takes to fall from maximum height back to the point of projection. With those few points in mind, let's see what I've been able to work out as far as this question is concerned. So first of all, I've tried to describe this motion by using this diagram. So the initial velocity vertically upwards, 30 meters per second. So that velocity continuously decreases with the time. And you can see I've taken the length of that arrow to represent the magnitude. So the length is quite big at the beginning, and then it reduces until the length becomes 0 at maximum height, where the velocity vertically upwards is 0. That velocity vertically upwards being 0 becomes the initial velocity vertically downwards. So the initial velocity vertically downwards will be 0. And then that velocity increases downwards. Like again, you can see the arrow is going to increase in length until when it comes back to the point of projection, the final velocity vertically downwards is 30 meters per second. So where we are using v as 0 because we are talking about motion of the object upwards, that v being 0 becomes u being 0 for the motion downwards. So don't get confused there. So that diagram, I hope, helps you to understand that. At the same time, on its way upwards, notice that the acceleration is minus 10 meters per second squared. I've already explained that it means the velocity of the object decreases by 10 meters per second every second. On its way downwards, notice that the velocity is going to increase. At what rate is it increasing? It increases at the same rate as it was decreasing rather. So here it was decreasing by 10 meters per second every second, and here it is increasing. On its way downwards, it is increasing by 10 meters per second every second. And of course, I've already pointed out that the velocity with which it is projected vertically upwards is the same, has the same magnitude as the velocity when it comes back to the same point of projection. And of course, in this question, there wasn't much because time is not a requirement. So we choose an equation which does not have t, and this is the third equation of uniformly accelerated motion. And when we look at upwards motion, v squared is going to be equal to u squared plus 2as. V at maximum height is 0. The initial velocity vertically upwards is 30, so I square that plus 2as. And I remember to put a negative sign there because it is moving vertically upwards. It is moving against the gravitational pull. And of course, once we do that, we get a height of 45 meters. So that first part is very easy. Let's look at the second part where we are asked, find the time that it takes for the particle to reach a height of 33.75 meters above the ground for the first time. I have underlined that for the first time because it comes back to the same height a second time, this time when it is moving downwards. So there are two times when its displacement is 33.75. The first time is when it is moving vertically upwards. We can call that one T1. And then the second time is all the way from the starting point to maximum height back to that same point of the 3.75 displacement, but it's moving downwards. Those are the two times for which its displacement is 33.75. So watch out for some of these terms that the examiner keeps on using. And then in the same question, we've been asked to find also the speed of the particle at this time. So I'm going to use an equation that allows us to find this, and I've already worked out this part, so let's have a look at it. So over here, I realize that I've been given the displacement of the 3.75. I know the u, which is 30 meters per second. I know a is minus 10. And for the whole motion, the acceleration is minus 10. So, when I substitute here, I'm going to get a quadratic equation. I'm going to get t squared somewhere. I'm sure when maybe you have tried to use this equation and you come across this expression here, many students get stuck. You need not be discouraged. Just ensure that it is as simple as possible. Then write that quadratic function in the form of ax squared plus bx plus c is equals to 0. Once you have that, identify the coefficients of x squared, in this time the coefficient of t squared, the coefficient of x, in this case the coefficient of t, and the constant c. Once you have identified all that, a is equals to 1, b is equals to minus 6, c is equals to this value here, then substitute it in the standard formula for solving quadratic functions or quadratic equations. So this one is an equation which I'd like you to remember because it can come in handy. And once you substitute into that, this time you know that the value of x is actually t. So you're going to get t is equals to 6 plus or minus the 3 divided by 2. This plus or minus means one of the values of t has 6 plus 3 divided by 2, which gives you 4.5. The other one will be 6 minus 3 divided by 2, which is 3 divided by 2, which is 1.5. So you can work out the two values of t. Of course, we had said that T1 will be the shorter one, but it really does not matter. It's just because here I could have, in fact, called this one to be T2. T2 will be 6 plus 3 divided by 2, which is 4.5 seconds, because it is a longer time. And then T1 is 6 minus 3 divided by 2, which is 1.5. What does this mean? This is what it means. That this particle takes a time of 1.5 seconds to rise to a displacement of 33.75. And then it goes to maximum height, where of course it takes 3 seconds, a total of 3 seconds, then falls back to the same point where the displacement is 33.75. And that time from the point of projection to where it is, we call it T2. In this case, I'm calling it T2, but in the calculation, it was actually T1. Okay? It takes 4.6 4.5 seconds. So here on its way upwards, it takes 1.5 seconds. That is the first time. That is the first time when its height from point of projection is 33.75. Then the second time when its height is the same is 4.5 seconds. I've seen other questions where they ask you to calculate the interval when the particle is above a certain value. I've also seen other questions where the particle is projected vertically upwards from the top of a story building, so that when it comes back, it bypasses the story building and moves all the way and hits the ground floor. All these questions, they employ the same concept. I've given you several questions in the video description so that you can be able to practice, because mechanics, if you want to understand mechanics, you must do as many questions as possible from these past papers so that you get to understand how the examiner frames certain questions. There is a standard way in which the examiner frames certain questions. And my work here is to show you how the examiner is framing this question, so that you don't have difficulties when you are reading the question, when you want to understand the question. Because sometimes we fail, not because we do not know what is supposed to be done, but because we do not understand what the examiner has asked us to do. Or sometimes we fail because we do not know how to get started. Many times I've marked these questions and I've seen some students will start a mathematical expression without even an equal sign. There is no mathematical equation without an equal sign, showing that this side is equal to this and some unknowns inside there. So don't do that. Try to emulate what you see me doing over here. And in the video description, I've given you several questions where you can do some more practice on motion under gravity. Make sure that you do those questions. They are not exhaustive. You could do more. And then when you find challenges, you could write in the comments and ask me any question which you feel like. In addition, I've given a link to one of my courses at Udemy, and it's called Mechanics 1. I've talked about these concepts in depth and step by step. So you will also benefit from that course. So just go to that course. There are a number of free videos that I have at the beginning just to give you a taste of how the course is like. And it is quite cheap. So go right ahead, purchase the course. It will actually take you a day or two to go through the whole course, and most of the concepts which you find difficult in mechanics will no longer be difficult. Now they will be easy. You will be able now to solve these questions with confidence. I'm going step by step like this because I've seen certain patterns repeat themselves in these papers. So when I give you a simple question like this one, and then I give you several so that you can practice on the same, make sure that you go through those. You can do more than that. In fact, the more questions you do, the better for you. Okay? And please don't forget to click on that link so that you can see how I have simplified all these questions in that course. See you in the next video.